So, all right, what is a power function or a function operation? We're going to kind of work backwards here. We're going to start with the function operations that are a little bit easier. So we're going to have usually 2, occasionally 3 functions, and we're just going to do the basic operations. Now again, it's just getting through all the junk. So for instance, in our example, our function f, we call it f of x, is 2x. Our function g of x is x plus 1. So when I'm asked to add them together, all I'm really being asked to do is write down f of x plus, write down my g of x, and I'll explain my infatuation here with parentheses. When I'm doing adding and subtracting, especially subtracting, those parentheses are going to mean something. Now in this case, to distribute a plus really doesn't do much of anything. So if I wanted to, I suppose I could distribute the plus. It's not going to change anything though. And then once I would get that set, I'd look for any like terms. And since we're just adding and subtracting, we don't mess with the variables, the exponents at all. 2x and 1x would be 3x plus 1, and I'd be set. Now the one new twist we get in here is domain, and there's no graphs involved with this. So how is this going to work? Okay, domain is when a bad thing could happen with x, when there's a restriction, when it would cause an error to happen. Well, the good news is when we're adding, that's not going to happen. Okay, so your domain, you can write it one of 2 ways when it's just something simple like this, and you're going to find out this is the answer most of the time. You can either say your domain is all reals, which just means I can plug in any number I want for x and I'm going to get an answer out. I can plug in a negative, I can plug in a positive, I can plug in a fraction, it doesn't matter. Or if you want something a little bit quicker, you like being the artsy scene here, we can do this thing called the double bar R, which is just a fancy mathematical way of saying all real numbers. Okay? But if you're asked for a domain, you have to tell me something. So whether it's all reals, this, or when we do find a restriction, getting that in there. And so as we kind of move down our options to subtraction, there's not going to be a whole lot different. The only difference is going to be, and this is one of those situations why having the parentheses is important, that negative's here now that we're going to distribute. Now that is going to change some stuff. Because now I've got 2x, the minus or the negative here is going to change the sign of my x, change the sign of my 1. So when I go to combine like terms, once I've gotten rid of the parentheses, 2x minus 1x would be x, or 1x, either one is fine, minus 1. But again, when it comes to my domain, all I've got to ask myself is there a number that I wouldn't be able to plug in for x and get an answer out in my calculator? No. I can plug in negatives, fractions, decimals, positives, it doesn't matter. So again, my domain would just be all reals. And again, write it out in words or put the little double barred R. Same thing. Why that did that, that should have been a multiplication dot. Okay, multiplication, same road. Multiplying things together. Okay, when we multiply, we do have the exponent rules that we need to follow. So when I distribute my 2x, thank you, 2x times x, I add my exponents, which would be 2x squared. And 2 times 1 is 2x. I can't combine those, because x squared and x are different. So as far as my solution goes, that gets me set there. Now, does that change anything going with my domain? Are there any numbers I can't square? No. Okay, are there any other numbers that I can't add in this case? No. So my domain, which is kind of starting to look almost like a pattern here, looks like it's going to continue to be all reals. You're like, so what you're telling me is when in doubt, just go with all reals, because I'm probably going to be right at that point. It's true. So here comes the last one. There's got to be something weird coming, because otherwise, why would you even make us do this? Okay, division. F of x, 2x. X plus 1. Keep the parentheses on, and here's the biggie. Here comes the post-it note. So here's the side thing that you don't have to write down, but you can kind of see. Here's why I use the parentheses especially here. There are people, every time, there will be even though I'm talking about this right now, that want to do this and say that's the answer. Okay? This bond right here is strong. The only way I can separate the x and the 1 is if I have another x plus 1 to cancel it out with. Can't do these pieces and parts here. So that's a no-no. Okay? We're going to stick with this. That's as far as I can go with this one. But here, finally, is where a domain can come into play. And I'll show you, not only just kind of using my head, but also how I could use the calculator if I wasn't sure, to see that there actually is a restriction. There's going to be a problem this time. Because when we're doing division, there's a certain number that we can't divide by. Now, you may remember it right off the top of your head, but if not, here's kind of our way we can double check when we get into a fraction situation. But I think once you see it once, you're going to be like, oh yeah, that makes sense. Okay, let me look at the chart here. So I start looking down my chart, and I'm like, okay, all these numbers are here to, -1, error. Why is that an error? I don't get it. Well, let's think about it for a second. Here, when you're doing fractions, your denominator can't equal 0. I can't divide by 0. If I plug in -1, right here, -1 plus 1 is 0. So how do I fix that? How do I make sure that my domain works with that? Well, what I do in a situation where there's a fraction is I'm going to take my denominator and I'm going to make a little equation out of it. X plus 1 can't equal 0. And I'd solve it just like I'd solve any equation. X can't be -1. Okay? I don't mind if you write for your domain. A couple ways you could do this. I don't care if you say x can't equal -1. I'm good with that. If you want to be really mathematically correct, though, we'd say all reals not equal to -1. But this is the restriction we're looking for. Okay? Whenever we see a fraction in an answer, and there's an x there, that's what we're going to set equal to 0 to make sure that we don't have that problem. Okay? But that's really going to be one of our only domain restrictions. There might be one other. We'll kind of see. But that's all we're trying to do, is kind of a little bit of simplifying. So, any issues so far? Because we're going to bounce around a little bit here on the bottom. We're not going to do all of these because I think it'd be kind of overkill. I want to make sure we're feeling okay. Friday. Yeah, our next quiz coming up is here at the end of the week. We're going into review mode as of tomorrow. Okay, so let's see here. What's another good one we can play with as we're working through these? Let's do a couple on number 2. We're not going to go crazy here. So let's do f and g on number 2 here. So f of x minus g of x. So f of x minus g of x. Ooh, we might do h. I see where that could be beneficial. Actually, that is what we're going to do. So I distribute my negative through. Changes the signs on both of those. And then again, I combine my terms that are alike. Negative 2 minus 1 is negative 3. X minus 3. And again, when I'm doing addition and subtraction like that, I'm not going to have any domain restrictions. Bless you. So if it's asked for, you can just say all reals or use your double bar R. Okay? But if it's not asked for, I really don't have to say much. Here's where people tend to get some issues, though, and this is why we're going to do this way. People tend to say, well, wouldn't those be the same thing? F of x minus g of x minus f of x? No. No, they wouldn't. So I've got to pay attention to the order here when I'm writing these. Because a few things can happen. Okay, here I don't have anything to distribute, so I can just leave it as x plus 3. What happens when you minus a negative? It switches my signs. So when I go to combine these, x and 2x is 3x plus 3. Okay, so it is a little bit different. Not a ton, but a little bit. But enough that we need to make sure that we've made that change. So, let's see, where else do we want to play? I'm just looking at one of these questions as we go here to see if we're going to tackle this for the types of problems we see. No, we're not. We're going to go this way. So we're going to go to number 4. Okay. So just kind of a reminder here again. We multiply them. Again, we're going to distribute that through. So we would add our exponents since we're multiplying. Negative 2 times 3 is negative 6x. And again, this is x squared, this is x. Those are not like terms. That's as far as I can go. And again, when we're multiplying, I can square any number, I can multiply numbers, that's fine. So my domain just stays all reals. However, if we change that up and go into the division mode, f of x divided by g of x. Again, keep the parentheses when we see plus or minus. It'll keep us from wanting to cross out things that we can't. I can't do anything else as far as that goes. However, fractions, remember, I can't have 0 in the denominator. So I take whatever's in the denominator, set it to not equal 0, and then just solve that mini equation. And again, I'm content with this or this for my domain. Okay, and just remind yourself, no 0 in the denominator. Okay, that's the big thing we got to remember on our restrictions. I'll spit it out yet. Just to make sure that we've got that in good shape. Okay, I'm not going to be obnoxious and go to the radicals. That's a little over the edge here, especially for day 1. Okay. The issues on the front before we hit our one new operation here. All right, so as we head to the back, here's our new one, okay? This is called a composition of functions, which basically means we're going to take one function, we're going to plug it into the other one. So here's how this is going to work. Notice here that there's two different ways we can write it. This is the one we're going to see more often, and you'll notice it's an open circled there, kind of like fog. Okay, it can put me into a fog if I'm not paying attention here. Different than the little dot than when we're multiplying. So what does this actually mean? Okay, so this is kind of a two-step process that we're going to be working on here. So we're going to do the inner substitution we're going to do that first. So you're like, okay, well, what does that mean? Depending on how it's written, if it's written this way, I'm going to do this part first. Okay? If it's written this way, it just means I'm going to plug this value into this first function first, the one that's closest to my number. Okay, they both mean the same thing, though. So here's how this would work. My first job is to do g of 2. Okay, well, what does that mean? Well, we remember from yesterday, g of 2 just means I'm going to take my g function, and when I get to x, I'm going to plug in the number that's in the parentheses. So I'm going to substitute in the 2. So 2 times 2 is 4, minus 1 is 3. Okay, now that's not my final answer. That just takes care of this first part, this g of 2. But we only got one more step. And our last step is we're going to substitute that into the other function. So once I've found my first value, my g of 2, my second job is to do the f function in this case, but I'm plugging in my answer from the first one. So I'm doing f of 3. And this may take a few before we kind of start clicking here. So here's my f function. My f function is 3x. So 3, number in parentheses. Okay, so here f of g of 2 is going to be 9. And yes, there will be 2 steps to every of these. Whenever time you get a composition, you're going to be doing 2 different substitutions in the same problem. We got to take our time, because if we mess up the first one, it's kind of going to be tricky to get the second one right. So as we play these, and again, we'll kind of keep looking at them both ways because they can be written either way. If it's written this way, I just do whatever's on the inside first. If it's written this way, I substitute the 3 into whatever letter's closest to it. So my first job here is to find f of 3. In other words, find my f function. That's what the letter in front tells me. So 3, and then plug in the value in the parentheses for x. Okay, when we're doing these, the idea is there aren't going to be any x's left at the end. We're always going to substitute a value in for them. And 3 times 3 is 9. Okay, so that's my f of 3 value. That's this value. So if that's the case, okay, if this is 9, now I'm looking for g of f of 3, or g of 9, my answer from the first step. So here's my g function. So 2 times x, but I know what x is. X is the number in the parentheses. Minus 1. 2 times 9 is 18, minus 1 is 17. Oops, and I did that backwards. G of f of 3 equals 17. The two places I see people have the most issue with this is making sure they get the right substitution the first time. Especially if it's written this way. People are like, well, which one do I plug it into? Just kind of keep working your way backwards, okay, from the number. That's going to be our biggest thing. And then just making sure that we're not putting x in there too, that we're substituting the x in. Now, these are the weird ones. F of negative 2. You're like, wait a minute, what? You're going to plug the function into itself? Yes. Okay? So when we get here, my first job is to find f of negative 2. Okay, so here's my f function. 3x. Remember, this is my x value, the number in the parentheses. So I get that one first. So I've gotten this part. This is negative 6. So now I'm looking for f of my answer from the first one. So the function hasn't changed. It's still 3x. So 3 times, but x now, the number in the parentheses, has changed. So f of negative 2 is going to be negative 18. And we're good. One last time, just so we can see it again. Then we'll chat for a second about some other little things we might run into here and there. All right, so g of g. Negative 4 is going into my g function first. So here's my g function. So 2, whenever I get to an x, and sometimes you may have multiple x's, we're just going to plug in what's in the parentheses. And then I just make sure I write everything else. So let's see, negative 8 minus 1 is negative 9. So that gets me this inner part. So now again, I'm still using the g function. But now I'm looking for the answer when it's negative 9. Same function. Different x value to plug in because the number in my parentheses has changed. So negative 18 minus 1 is negative 19. So g of negative 4 is going to be negative 19. So just keep reminding yourself of that. Just work yourself inside out when you're trying to do that stuff, and it'll be easier with those operations. So, all right, I see 2 down here I want to tackle, which will be similar to some of the ones we're doing. We're going to look at number 9 and 13, and then I think we're okay. All right, so 9, more division. Okay, so we got f of x, x squared. For g of x, x minus 3. Remember, the parentheses are our friend, so we don't do something silly like try to cancel. But when we're looking for the domain, fractions are the one time we got to think about this. Otherwise, they're always all reals. But here, I've got to make sure that that denominator does not equal 0. Solve it like you would any equation. I'd add 3 to both sides. I'm fine with you writing it this way, or again, all reals not equal to 3. But for the addition, domain's all reals. Subtraction, all reals. Multiplication, all reals. Division is the only one where I got to do some thinking. And then finally here, just to make sure this composition stuff is okay, we're going to look at 13. So on 13 again, start on the inside. So I've got g of 3. So g of 3 would be 5 times 3 minus 4. Because I'm substituting the value in the parentheses in for x. 15 minus 4 is 11. Then I work my way out, so I'm working inside out. I'm going to be doing f, but now I know what this value is. It's 11. So here's my f function. I'm going to be plugging in where the x is. So when I get to x, I replace it with the number in the parentheses. Everything else stays the same. 33 plus 2 is 35. And that would be f of g of 3. And the only other thing I'll mention before I kind of let you loose here is, again, knowing the difference between a composition and multiplying. Number 12 is multiplying. Okay? This could also be written. So you'll notice it's kind of a similar type look, but again, the circle will be open on a composition like it is up in number 5, but if it's just like a little pen dot, okay, that's multiply. So I would just FOIL or I'd box those out and get my solution that way. Issues. This is going to kind of roll back again here for the next couple of days. So good to get practice today, and then we can reinforce then. And so the assignment that goes with, again, is not the book part. It's this Power Functions Day 1 worksheet. No, there's going to be an extra credit coming tomorrow, though. Correct. We are going to skip the book stuff. So here, just watch for the sign. Is it plus? Is it minus? Is it times? Is it divide? Those types of things. And on the back, it starts getting into the compositions. Again, little dot is times. Open circle is compositions. So basically, once you hit number 13, it's compositions from there on out. So like I've mentioned before, do enough that you're comfortable. Maybe start with all the odds or all the evens so you're getting a little bit of a mix. And if you're having some struggles, that leaves the other ones to do if you need those. But the key is always up front, and if you try one out and it's not matching the key, see me. It's probably just some little thing that we need to take a peek at to help you out.